So welcome to this latest video on 162 Maths, and in this video we're going over Pythagoras and trigonometry when the two topics are combined. Now before going through some past exam questions that involve these two topics, I'll recap both the two topics, and if you're wanting a copy of the questions then all you need to do is just simply click on the link in the description below. Now before we get started working through some questions, let's just have a quick recap on Pythagoras and trigonometry. Now Pythagoras and SOHCAHTOA trig only work with right angle triangles. Pythagoras is used generally to find missing sides only, whereas trigonometry is used to find not only sides but angles inside that right angle triangle. Now for non-right angle triangles we must use either the cosine rule or the sine rule to find the missing lengths or interior angles, which again is covered in another video. Now to use Pythagoras to find the side of a triangle you must know the other two sides of the triangle, and for trig to find a missing side you need to know either an interior non-right angle triangle and one of the other sides, and to find an angle you need to know two sides of that triangle. So let's now have a look at the formulas. Now with the formulas you're probably all accustomed to. So with Pythagoras' theorem it's a squared plus b squared equals c squared, and c is always the side that is opposite the right angle, so that's always going to be the case. Now when it comes to a and b, that can be basically they're the two shorter sides, so it doesn't really matter which one you call a or b. Generally if you're finding the shorter side, I would always start by calling a the x, just to make solving the equation that little bit easier for you. Now when you move on to trig, here not only is the right angle dictating which sides are which, but it's also the angle, the interior angle in question as well, because although the right angle dictates which side is going to be the hypotenuse, because it's always the opposite side, so we label that h or hip, theta dictates where the opposite is going to be. So as theta is on the base, then this side here is going to be the opposite, whereas if theta was here, then the opposite would be there. So just to save confusion, let me just get rid of this. And the side that contains theta and the right angle is what we call the adjacent. And then it's just deciding which of the three formulas you need to use, which again is typically remembered by using SOHCAHTOA or any rhyme that you may have to help you work that out. So let's get started working through these questions. Now again, a copy of these questions are available for you to download and have an attempt at before continuing watching this video. So we go through the answer, and all you need to do is just simply click on the link and download the document. So for question 1 it says use this diagram to write down the value of tan x. Now tan x is equal to the opposite over the adjacent. So if this angle here is x, the opposite is going to be this side here, and the adjacent is going to be the side that has the right angle and x, which is this side here. So then using O is 3 and A is 4, I can then write tan x as 3 over 4. So the answer then is 3 over 4, or if you want to write it as a decimal, 0.75. I personally would leave it as a fraction. Moving on to question 2, it says work out the length of x. So again, what we need to do is we're going to use trigonometry because we've got sides and angles. So then labeling this up, I know this is going to be my hypotenuse, this side here is going to be my opposite, and this side here is going to be my adjacent. Now as there's no information on the O and I don't need to find it, I can just get rid of that. So then next is for me to establish which trig ratio uses A and H, and it's going to be cos. So I've got cos 35 equals x over 22. So then doing a bit of rearranging, I get 22 multiplied by cos 35, and that equals x. Then all that's left for me to do is just simply type that into my calculator, and I get an answer of 18.02134497, and all that's left for me to do is round this up. So I'm going to write x equals 18.0 centimeters, and again don't forget to include the units, because usually if there is no mention of the units you'll get a mark for that, and that's been rounded to 1 decimal place. Moving on to question 3, it says work out the size of angle A. So again, I'm assuming that it's a right angle triangle. So first of all, we know that this is theta, this is going to be the opposite, and this side is going to be the hypotenuse. So which trig ratio uses O and H? It's going to be sine. So we've got sine A equals and it's going to be 7 over 12. So then to work out a, it's going to be the inverse sine of 7 over 12, which if I type that into my calculator, I get an answer of 35.7, and that's to 1 decimal place. Moving on to question 4, it says work out the value of x in this question. So again, labeling the triangle, this side's going to be h, this side's going to be a, and again it's not Pythagoras because I'm not working out, I don't know two sides of the triangle. I'm not also wanting to know the third side of that triangle, so it's going to, and it also involves an angle, so it's going to be trig. So then from this we're going to use cos again. So we've got cos 42 equals 18 over x. Now again, if you use the triangle method of the trig ratio, so here we've got cos and we've got adjacent and hypotenuse. Now in this case I'm wanting to work out the hypotenuse, so I do that by doing a over h, cos, sorry, so it'll be cos 42 equals h, and h is x and a is 18, so it's going to be 18 over cos 42 equals x. So then just type that into my calculator, in which I get an answer of 24.2, and that's to 1 decimal place again. Moving on to question 5, it says consider the triangle, decide whether each of these statements is true or false for this triangle. So let's have a look at this first statement. So the first statement says that a squared equals c squared minus b squared. Now this is using Pythagoras. A is one of the shorter sides, so it's going to be the longest side, which is c. Take away the square of c, take away the square of b, so that is true. For the next question, it says sine b equals b over a. Well, if I just rotate that triangle and have this angle as my b, this is my right angle, and just label accordingly. So that's going to be c, the opposite is b, and this side here is a. So looking at this, using sine, I've got to use the opposite and the hypotenuse. So sine b equals b over c. So this statement here is going to be false. Then for tan a, so if I draw tan a, or the triangle of a, where a is at the bottom here, this is the right angle. I'm just labeling across. This is c, that's a, and that's b. So tan theta equals opposite over adjacent. So here my opposite is a and my adjacent is b, so it should be a over b, and that's correct. Then moving on to the last one, it says sine a equals cos b. Well, taking this particular triangle here, we know that sine a is going to be equal to the opposite over the hypotenuse. Now in this particular triangle, the opposite is a, and the hypotenuse is c, so it's a over c. Then taking cos, so if I use this triangle here, that cos b is equal to the adjacent over the hypotenuse. And in this triangle here, the adjacent is a and the hypotenuse is c. So as you can see, both of them both equal a over c, so that is going to be true. Moving on to question 6, it says the diagram shows a plot of land, and it says a fence is built on the perimeter of the land, and the fence costs £20, 50p per metre. Work out the cost of the building the fence. Give your answer to the nearest pound. So first things first, what I need to do is I need to work out what these two lengths here are going to be. Now if I know that that's 20 metres, this bit here, so what I need to do is I need to work out what this length here is. I'm just going to call x, and I need to know what this length here is going to be, which I'm just going to call y, which means that that's also going to be y. Now if I take that triangle out, so if I just highlight this right angle triangle, preferably not in blue, so if I highlight this triangle here and I take that triangle out, so let's just draw that triangle here, then I know that this is 60 this length here is x, and this length here is y, and that is 50. Now, to work out, if I just ignore the y to begin with, and let's just work with this triangle. So then labeling the parts, this is the hypotenuse, this is the opposite, the adjacent rather, and this is theta. So which trig ratio uses a and h? Well, that's going to be cos. So I've got cos 60 equals, and it's going to be x over 50. Now, cos 60 is an exact value of trig, in which cos 60 is just a half. So this could appear on a non-calculated paper. So cos 60 equals a half. So I've got half equals x over 50. Then doing a bit of cross multiplying, I get 2x equals 50. So x equals 25. So this length here is going to be 25 meters. I can then, moving on to the next triangle, so if I just get rid of x and let's bring y back into play. And so from this, I could have used Pythagoras because I know the other two sides, but I'm going to stick with trig. So using y, I've got, this is the opposite, this is that, h is the hypotenuse. So I'm going to be using sine, so sine 60 equals y over 50. Now sine 60 is another exact value of trig, which is root 3 over 2. So it's root 3 over 2 equals y over 50. So it's going to be 50 times root 3 over 2. Now this isn't going to be a non-calculated paper, so I can just work it out. So 50 times the answer gives me an answer of 43.3 to 1 decimal place. So I can then write that as 43.3. So next, all that's left for me to then do is work out the perimeter of the fence. So the perimeter is going to equal, and it's just all those lengths added together. So it's going to be 50 plus 25 plus 20 plus 43.3 plus 20. And if I total all of that up, I get an answer of 158.3. And all that's left for me to do is just multiply this length by the price per metre. So it's going to be 158.3 multiplied by £20.50, and that comes up to a general cost of 3245.15, but the question says give your answer to nearest pound, so it's going to be £3,245. Moving on to question 7, it says work out the area of the parallelogram. Now the area of a parallelogram is basically the base times the height. So what I need to do here is I need to work out what h is. Now obviously h, with using trigonometry, is commonly used for the hypotenuse, so let's just call that x. So if I take that triangle out, I know that this angle here is 68, this is 15, and I want to know what this side here is going to be. So then labeling the triangle, that's h, that's o, so I'm going to be using sine. So sine 68 equals x over 15, so x equals 15 times sine 68. So x equals 15 sine 68 equals. Now, one thing you could do is just leave it as this. Now, the answer is 13.9077, blah, blah, blah. So you could either use 15 sine 68 or 13.9077, depending on how accurate you want to be. So then the area is going to be 15 sine 60. I'm going to use the exact value multiplied by 18, as it's still on my calculator, and I get an answer of 250.3, and that's to 1 decimal place. Now, depending on your rounding, you might have an answer that's slightly off that 250.3, but again, that should be accepted. Then moving on to question 8, it says 2 right angle triangles are put together. Calculate the length of y. Do not use a scale drawing. So first things first, what I need to do is I need to work out this length here. Now I can do that by using Pythagoras because I know the other two lengths. So if I just start by calling that red line x, take that triangle out, just so it's a little bit easier for me to see. So using Pythagoras, I know x squared equals 13 squared plus 8 squared. So x squared equals, and it's 13 squared plus 8 squared, which is 233. So x equals the square root of 233. Now again, I could write that as a decimal, but I'm just going to leave it as a surd. So then taking this triangle out, I've got this is 28. Y is what I'm trying to find. I know that this length here is root 233. So labeling the triangle, that's h, that's going to be a, and theta is 28. So I'm using cos. So cos 28 equals root 233 over y. So then y equals the square root of 233 over cos 28. And if I just work that out, I get an answer of 17.3, and that's to 1 decimal place. Then moving on to our last question, it says the cuboid has sides 4 centimeters, about 6 centimeters, and 12 centimeters. CH equals root 180. It says calculate the size of angle CHB. So let's first of all just mark down, make sure that everything's checked. Yeah, and so C to H, this diagonal length here is root 180. Now to work out the size of angle CHB, let's first of all find out which angle it is actually wanting me to go. So it's C to H to B. So it's this angle here that I'm wanting to find. So if I just start by labeling that as X. Now if I take that triangle out, then what I end up with is X, this length here is root 180, and the height of that triangle is 6. So then using tan, I've got tan x equals 6 over root 180. Then do the inverse tan of 6 over root 180 to work out x. So here I've got inverse tan and on the calculator it gives me an answer of 24.1, and that is in degrees to 1 decimal place. Then the last question, it says using your answer in part A, work out the size of AGF. So let's first of all have a look at where AGF is. So A is here, G is there, and F is there. So let's draw, so it's this angle here that I'm wanting to find. Now, this is obviously a right angle. Now, in terms of this angle here that I found in part A is going to be the same as this angle here. So that's going to be 24.1 also. And the question is asking me to find this angle here. So let's have a look at working that angle. Well, to work that angle out, all I need to do is, because I know angles add up to 180, so if this angle here is 90, then all I need to do is do 180 minus 90 minus 24.1, and 180 minus 90 minus 24.1 gives me an answer of 65.9, and that's to 1 decimal place. And there we go.